Hi, it's Professor Sills again, and apologize if I lost track of where I left off, but I think we were on number 15, chapter 11, page 310. Based on the following weather forecast, what type of front will most likely pass the area? Well, when we talk about fronts, again, you saw a visual on that before. What we're talking about is the idea that if you have light rain and cold weather for letter A today, temperatures just above freezing, then turning colder with rain becoming snow, you've got a cold front passing through. I mean, think about it. When you think of a front, warm air ahead, cold air behind with a cold front. So if it gives you the clue that turning colder, cold front. Letter B, cool today with rain becoming heavy at times, warmer tomorrow, warm front. You're probably up here, and the warm front is headed northward. The semicircles show the direction of movement. And as that warm front moves north of your area, remember what I showed with the visual, what you're going to have is warmer air moving in. Looking at letter C, increasing cloudiness, warm today, possibility of showers by evening, turning colder tomorrow. Where you are is you're here. You're in the warm sector, you're in warm air, and as the cold front approaches, you have the clouds moving in. We can show cloud amount here. You might be right about here with the clouds approaching, and the showers are associated with cumulonimbus clouds or with cumulus clouds. So right along the front itself is the cold front, is where you have your greatest lifting and your showers occurring. Looking at D, increasing high clouds and cold this morning. Clouds increasing and lowering this afternoon with snow or rain, followed by warmer. Well, you're up here. You're in an area where you've got these layered clouds. You're going to get a prolonged period of snow and rain. Warm front moves north of you, and you're in the warm sector, and of course your rain ends and it gets warmer. 16 side views of the cold front and warm front. Just go back to the videos that you had before. And just to review those.
A turkey and a bowl of broccoli. A turkey and a bowl of broccoli.
I'm in a Panera Bread, so you just heard. You caught me. Let's see. For the fronts, let's just review those. This is a cold front. And again, if you're here, a cold front is approaching you and moving through. Now you're in the cold air. You're in the warm air here. I'm leaving my finger where it is. Now you're in the cold air. And if we look at the clouds, those clouds would be a vertical development. Why? Because the surface winds are being forced to rise rapidly ahead of the cold front. The cold frontal surface is steep. All right, that's an important point to get. Now, if we switch over to a warm front, the warm frontal surface is much more gradual. That's the surface here. So if I'm here and the warm front is now about to pass me, the warm front passes by, I've got the change into the warmer air. What kind of clouds? The layered clouds, the stratiform clouds. All right, let me turn this off and turn this off. Okay, during spring on a warm sunny day in Boston, the wind shifts from southwesterly to northeasterly. What have we got going on? What we've got going on is a high pressure system, probably continental polar, has worked its way out to a position here. And when the high pressure system is sitting here, the winds will blow around it clockwise, pushing in air from the east. Boston's right about here. Springtime, think cold water. I mean, as I record this on April 24, 2010, think about it. If you went to the beach today off the coast of New Jersey, the water's probably about 40, 45 degrees. Up off the coast of Boston, it's probably still in the high 30s. So that's very cool, damp air coming in, and that would be maritime polar air. So if we skip into the questions for thought, go through these real quickly. How an anticyclone in autumn can bring record-breaking low temperatures, continental polar air to the southeast. Well, a low like this that tracks northeastward, if we track the low, watch what happens. The cold front tracks along with it, and as it passes through the southeast like you see happening here, if this is a very cold continental polar Arctic air mass, the winds are going to be blowing from the north in the southeastern states, or northeast. It's really more of a northwesterly wind to be seen here, but well, we'll work with it, northeast wind. It's going to be cold air. Bottom line, you're going to have potentially record low temperatures as long as that air mass is from sufficiently cold air. Chicago, Illinois to experience heavy lake effect snow. If we back this up, and we've got the low pressure system right about here. Up in Chicago, if I move my marker, I've got a northeast wind. The air is coming off of the lakes, so that I've probably got snow coming down, not only courtesy of the cyclone, but courtesy of positioning along the Lake Michigan region. When a cold air mass covers half the U.S. and warm air mass covers the other half, explain how it happens, just like you're seeing right here. At this time of year, and of course in the winter, in January, February, March, you can very easily have very cold air to the north, lower solar angles. That's why I had you study seasons. Down here you have higher solar elevations. Imagine a high pressure system here. This is maritime tropical air, this is continental polar air, and this is the dividing line, and the cyclone or low pressure system is right along it. We'll look at cyclogenesis when we get into chapter 12. Skipping to number 9, why does the same cold front typically produce more rain over Kentucky than western Kansas? Here is western Kansas. Here is Kentucky. Kentucky is in a proximity where Gulf moisture can get in, and you're going to pick up more moisture in the air, therefore more rain or snow, as opposed to western Kansas, where the Gulf of Mexico really doesn't have as much of an effect. In fact, in the summer, if you ever drive from eastern Kansas to western Kansas, it's 400 and some odd miles, and the dew point will go straight down. The same thing happens in Texas. Start here in Houston. I can't think of any place I'd less rather be in the summer than Houston, with high temperatures and high humidities. By the time you're in Amarillo, you've got high temperatures, but very, very low humidity. Why? Very low dew points. All right, looking at number 11, Lake Erie freezes over. That's it for the lake effect snows. Why? You've cut off the moisture source. And number 12, ocean effect storms, fairly common, with a persistently northerly wind over Cape Cod, but not as over Long Island. Just look at it. Look at your proximity. And let me get rid of our cyclone here for the moment. If you're in Cape Cod, you've got a north wind. Where's the wind coming from? The water. If you're in Long Island, where's the wind coming from? If it's a north wind, from the land, from New England. Therefore, drier air coming from New England, whereas if you're out over the Cape, you've got moist air coming off of the Gulf of Maine. With that, I'm going to create part 3, which will effectively be your chapter 12 assignment.